Hey everybody! So this video we're learning about how can you separate mixtures, because there are lots of different situations when you'll need to separate things out, in science and in everyday life too. So the first situation is, what if you just have a mixture of cars all randomly jumbled up, or if you have a bowl of fruit salad here. These objects are It's really easy to tell the difference between them, and they're pretty big too. So in this situation, we can just use a method called simple separation. And in simple separation, all you would do is physically pick up different parts of the mixture and set them aside. So you're separating them, like you would drive all of the red cars to one place and all of the yellow cars to another place. And with the fruit salad, you would pick all the different fruits and put them in a separate pile. So simple separation is just taking and physically moving the objects to separate them. So after we use simple separation on these situations, we would end up with something like this. So the mixture of cars has been separated and the fruit salad has been separated. So that's the easiest way we can separate mixtures, but there are a few more we can use too. So the next case is, what happens if you have a pile of coins like this, and some of them are real coins, which are not magnetic, and then you have some fake coins that are mixed in there, and fake coins are made of iron, which is magnetic. So you can't tell by looking at the coins how to separate them, but we know that some are magnetic and some aren't. So for this, we can use magnetic separation. Which the name pretty much says it all. You take a magnet, a nice big strong magnet, and you hold it over the mixture, and it will collect only the fake coins, which are made of iron, and all the real coins will be left behind. So you'll have two piles. You'll have the fake magnetic coins and then the real ones. So you've managed to separate the mixture. So magnetic separation it uses a magnet to separate, and it can only separate magnetic things from non-magnetic things, and iron is the most common magnetic material. So it uses a magnet to separate iron from other materials. And the benefits of it, the positives, are that you can even use it on materials that look the same, like these coins. You couldn't tell what the fake ones are, but the magnet will just know what they're made of. Can be used on similar looking materials. Okay, so the next situation. If you've ever been camping and you've had to go and collect water from the river or maybe a lake or a dam nearby, sometimes that water is really muddy or full of clay. So here we've got a mixture of clay and water. And if you want to drink this water, it's not going to taste particularly good. So you want to separate it out. So you just have the water. Well, what you can do is a method called sedimentation. And it's pretty simple. All you do is leave the mixture out for a few hours, and eventually all that clay or sand will fall to the bottom of the container, and you'll have fresh water at the top. And then you'll have the clay at the bottom. So sedimentation is just you're waiting for the sediment to fall to the bottom. And the sediment is what we call the solid part of the mixture. And probably the main benefit of sedimentation is it's easy and cheap as well. One of the negatives though would be it doesn't work for every mixture. Some mixtures, like milk, there's no sediment. So even if you leave milk out for weeks, there are no solid particles that will fall to the bottom. So you can't separate milk from the water that makes it up using sedimentation. So it doesn't work on every mixture. But really useful if you are going camping or bushwalking. Okay, so if you've got to that stage of having used sedimentation, you might have a container that's got the liquid at the top and then the sediment at the bottom, like we just said. But you might want to separate it again so you actually have the liquid in a different container, so you can go and take the water off in your drink bottle without taking the sand with you. So this method, it sort of follows on from sedimentation. It's called decanting. And in decanting, you take your mixture. It might be a liquid and a solid, or it might be two liquids. So this one is oil and water, but you can still decant that. What you do is you carefully pour the top liquid into a different container, often using a spoon or a plastic rod if you have one. So you pour out the liquid and you carefully leave the sediment in the bottom of the container. And you slowly pour the liquid off the top. So in decanting, you pour the liquid off another material, which could be anything that's settled at the bottom. So the positives for decanting, it's easy. You just take up the container, pour the liquid off the top. The only problem is it will usually leave a tiny bit of that top liquid in the container. So in this one, there'll usually be a little bit of oil left at the top that you can't pour off perfectly. So decanting is not perfect. That's the downside of it. But hopefully at the end, you'll have two separate containers with mostly separate and pure substances. Okay. Here's the next example. So often you'll find in the soil or out on the nature strip somewhere, there might be polystyrene bits all spread out in the soil. Polystyrene, it easily breaks off. It's found in a lot of packaging, like when you buy a new fridge, and often little pieces break off and they get blown off into the soil. And the problem is they don't break down in the soil at all. They're not biodegradable. Polystyrene. It's not biodegradable, and if it makes its way out into rivers and the ocean, it can harm sea life and other wildlife because they can ingest it. So polystyrene is a really bad waste to be out in the environment. So a lot of environmental groups want to try and clean up polystyrene and separate it out from the mixture of the soil. And one of the best ways they could use is the next method, which is called flotation. And it's all in the name as well. Flotation, think of floating. So if one material in the mixture floats, you can pour that mixture into water, and then the material that floats will float to the surface, and all the other parts of the mixture will fall down to the bottom. So pour the mixture into water, and some of the materials will float. Hopefully just one of the materials that you're trying to collect. So here you can see polystyrene floating on the water, and then we can easily collect those with a net or decant them off the top. Okay, here's the last method, and it's a really common one that you do all the time, but its proper name is called filtering. So filtering is using a filter to catch some of the materials in your mixture, but not others. And the key thing is, it catches it because a filter has holes in it, like a sieve, then small materials can go through it, or liquids, and larger solid materials get caught. So filters, they separate mixtures based on the size of the objects. So our example for filtering is when you're cooking pasta. You've got a mixture of pasta and water, but you don't eat pasta in a bowl of water. You need to separate out the water and the pasta. So what you do is you take your colander or your pasta strainer, which is just the name we use in the kitchen for a filter. And the water passes through the holes and it separates the water from the pasta. And then we're ready to have dinner. Filters are in a lot of other places too though. There's filters in vacuums. They filter out the dust from the air. They're also on your doors and windows. Because a fly screen, it lets air through the holes, but it stops insects and dust, or big dust particles, coming inside. So a fly screen is a filter too. Okay, that's all the basic methods of how we can separate mixtures.